All right, this is number three, or like the last recording that I could do, which we left off on the sketch pad. So let me just share this last portion. And we have this basically, right? We were left off with a parentheses b minus c close parentheses to the power of 2 divided by 2 plus d, right? And they're telling us to basically evaluate when a is equal to 2, when b is equal to 4, and when c is equal to -3, and when d is equal to 1. So we just plug it into our expression. So notice wherever we see 2, and wherever we see a, I'm going to plug in 2, which I did. I saw b is 4, so I plugged in 4. C is -3, so I plugged in -3. D is 1, and that's my thing. So let's do the math, right? We know that the special case, right? What's the special case? Well, the special case, if there's a minus and a negative, this becomes a plus sign, right? So that becomes now 2 parentheses 4 plus 3 to the power of 2 divided by 2 plus 1. I believe that's what it said. Yeah. All right. And so now let's just do this. What is 4 plus 3? Well, we do 4 plus 3 and keep everything the same. Power of 2 over 2 plus 1. 7 to the power of 2, or 7 times 7 is 49. So we bring that down here. It's going to be 2 times 49, and then 2 plus 1. All right. What is 2 plus 1 in the denominator? That's 3. And then what is 2 times 49? 2 times 49 is 98, right? And we can kind of simplify this. 98 divided by 3 is going to give us, it's going to give us a weird number. So we could kind of leave it as it is, or we could do the, what's it called? Making this fraction into a whole number. So how many times can 3 go into 98? It's 32 times, right? What's the remainder? 3 over, oh, it's not 3, it's 2. It's going to be 2 over 3, right? Because 3 goes into 98, or 3 times 32 is 96. 98 minus 96 leaves us with 2 as a remainder. You can leave it as this or as that. Both are correct. But uh, that's evaluating expressions. All right, so let's share back to our PowerPoint. All right. So all we really have to do is just plug in whatever values it's telling us. So look at this one right here. It's saying 4 plus 3, parentheses, x plus 4, close parentheses to the power of 2, when x is equal to 6. So I plug in that 6 into that x, and I just do the math. 6 plus 4 is 10, to the power of 2 is 100, times 3 is 300, plus 4 is 304. But let's actually do that here. Just get more practice. Let me see. All right, we said, what was it that we said? We said 4 plus 3, parentheses, x plus 4, close parentheses to the power of 2, when x is equal to 6. Let's plug that in. Right, 6 plus 4 is 10, like we said. To the power of 2 is 100. Right, we bring down the numbers that were left over. Right, remember, based on PEMDAS, right, we still have to do multiplication first. So what is 3 times 100? Well, that's 300. And then we add 4. Right, because 4 comes in the end. 300 plus 4 is 304. And that's how we get our answer. All right. I think, wait, perhaps we might have another question that we could work on. Time being. Oh yeah, it was, I think it was in the, oh yeah, we could kind of do this one. I think this was on the classwork. All right, so in the classwork, we kind of have this example. We have x to the power of 3 minus 2x to the power of 2 minus 3. And they're telling us evaluate when x is equal to negative 3. Means I'm going to plug in negative 3 into every x I see. So minus 2 times negative 3 to the power of 2 minus 3. So PEMDAS tells me parentheses first, exponents, multiplication, division, addition, and subtraction. Parentheses, there really aren't any parentheses, but there are exponents, right? It's negative 3 to the power of 2 and negative 3 to the power of 3. So let's not forget that this means negative 3 times negative 3 times negative 3, right? That's what it means. We're going to multiply negative 3 by itself 3 times. And what is that? What is negative 3 times negative 3? That's positive 9, right? Negative 3 times negative 3, same sign, positive. But then when you do negative 3 times 9, that becomes negative 27. Why? Because we're multiplying two numbers with different signs. So it's always going to give us a negative. But on this side, we have negative 3 to the power of 2. Remember that this is saying negative 3 times negative 3. And we know that when we multiply signs with when we multiply numbers with the same sign, it becomes a positive. So this actually becomes positive 9, right? There's still that 2. So let's bring that minus 2 down. And then it becomes what is negative 2 times 9, which is going to be negative 18. And then we bring down that 3. That's all along. So we have negative 27. We have negative 18, or minus 18, minus 3. Well, we did all the multiplication, right? We did the multiplication here. And we did the multiplication. Well, this is part of the exponent. There was no division. There's no addition, but there is subtraction. And that's our last step. What is negative 27 minus 18 minus 3? We get minus 48. Okay, and that is our final answer. Guess another thing on the practice exam too, or the worksheet was something like this. We had 4 plus 2 bracket 6. Whenever we see brackets, it's basically like they kind of act like parentheses. There's like a parentheses before another parentheses, if that makes sense. Um, right, so basically, according to PEMDAS, right, parentheses goes first. Well, we have a big bracket, so that means we got to focus on this part inside first, right? Then we have exponents, usual, multiplication, division, addition, subtraction. So there is parentheses. We're hit with this outer parentheses, the brackets. But then inside of it, we also are hit with another parentheses. But notice how we can't do 5 minus 3x and x minus 7 because they're not like terms. We can't combine them like how we learned in the other portion. Can't combine them. So what we can do is something called distribution, which we did learn, and it was part of the properties of real numbers. So we're going to distribute these numbers in, and that becomes what? Well, 6 times 5 is 30. So I'm going to rewrite everything down. It's going to be 4 plus 2 brackets. It's going to be 30. What is 6 times negative 3? Well, that's negative 18, right? Oops. All right. Now, you could either do 9 first or just the minus, right? So, sorry. So what is negative 9 times x? Well, that's negative 9x. What is negative 9 times negative 7? So negative times a negative is going to be a positive, and that is going to give us positive 64. Not 64, sorry, 63. All right. We close our parentheses. So do we still have parentheses? Yes, we do. We got rid of the parentheses inside through distribution, but we still have these brackets which act like parentheses as well. So let's combine like terms in the inside. So we have 30, which is a constant. We have 63, which is a constant. We have negative 18x and we have negative 9x, which are both like terms because they both share x. So what is 30 plus 63? Well, that is 93. We still keep our brackets. What is negative 18x minus 9x? That's minus 27x, right? We have a 2, we have a 4. Can we combine these two like terms? No, we cannot, right? In this bracket, we have 93 and negative 27x. We can't do nothing with those two because one's a constant and the other one has a variable, which is x. So we can't combine them. But what's next is we could actually distribute 2 in the inside, right? And so when we distribute that in the inside, we are given, sorry, there's addition sign there. We are given 4 plus, what is 2 times 93? It's 186. Positive 186. What is 2 times negative 27? That's going to be negative 40. Sorry. It'd be negative 54x. Last but not least, on our PEMDAS, right? Well, we already did all the parentheses we can. There was no exponents. We did multiplication, sure. Um, maybe not really any multiplication. There was no division. Now we just do adding and subtracting, right? And when we get to like the last steps, like adding and subtracting, we could just read it as it is. So we could do 4 plus 186. Um, actually, I apologize. We're just going to add these portions, right? Because notice how this is a constant and that is a constant. This one, however, the negative 54 has a variable inside, so we can't really combine it with the rest. So we just do what is 186 plus 1 plus 4, and that is 190. And then we have that negative 54x. And that is how we combine and simplify expressions. Okay, so that was on the classwork. And that's how we would observe and do it. All right, so last thing that we did not get to talk about is interval notation. So I'm pretty sure everybody has seen um, inequalities, right? For interval notation, right? We kind of deal with greater than, less than, greater than or equal to, less than or equal to, and what the sign is basically, I always called it the alligator. It's always trying to eat the larger piece. So wherever you see this open mouth or this, opening is means it's going to eat the larger number, right? Because it's, I don't know. That's how I viewed it when I was little, right? It's an alligator trying to eat the biggest portion of food. So that's why it's open towards the larger number. Um, but anyways, there's sorry, there's greater than, there's less than, there's greater than or equal to, and less than or equal to. All right, we usually see an inequality like this. X is less than 4. So the way we see it or the way we view it is that it's all the possible numbers that X can be that will be smaller than 4. So think about 3. 3 is smaller than 4, so 3 can be an X, right? Think of all the possible numbers that X can be as long as it's less than 4. So we have 2, we have negative 5, we have negative 30, and to be honest, negative infinity, right? Because that's all smaller than 4. It cannot be 5 though. X cannot be 5 for this first um, example because 5 is not less than 4. So that's where X draws the line. Then we have X is greater than 6. That's another way we could see it. And basically, we view this as all the possible numbers X can be that will be greater than 6. So we have 7, 8, 9, 10, 11, and so on, all the way to positive infinity. Sometimes we see double inequalities like this. 2 is less than X is less than 8. We view this as all the numbers X can be that fall in between the number 2 and 8. So that means numbers like 3, numbers like 4, 5, 6, 7, but not 8 because it's not included. All right. It's kind of blurry, but basically that's how it looks like, right? We have numbers like this. A is less than X is less than B. That means they're not included, but it's all the numbers in between A and B. And we use these parentheses. If we have the less than or equal to, then we have brackets. So that means it is included. That means that X can be A, but it has to be greater than A as well. And it can be B, but it has to be less than B as well. Then there's a combination of both. You just have to be careful how you read it. Here it's saying X has to be greater than A, but it cannot be A. And it could be less than B, but it could be B because of that equal sign. This is kind of the same thing, but in general, right, when we'll do examples. I think examples work way better when we're dealing with this because it's kind of confusing at first. Just math on a theoretical level or like algebra, like when you try to explain it algebraically or properly, it sometimes looks very strange and doesn't make any sense. But then once you do examples, it kind of does. So the first thing we got to know is not included. Oh, why the hell does it do that? I do another paper. Okay. So we have not included, and then we have included. Excuse my handwriting, I'm writing with my finger, but we have not included and included. What that means is we have less than, greater than. And when we're dealing with these inequalities, when we graph them or we kind of show them in interval notation, we either use parentheses, right? Or if we were to graph it on a number line, we use open circle, right? Now, when it's included, we use this. Greater than or equal to, less than or equal to. We use brackets, and then we use a circled or a filled in line. If we were to graph these, which I think eventually we will learn how to graph it, the lines when we graph have to be dotted. And then here could be solid lines. So these are all ways to kind of explain that they're included or they're not. This will make a little bit more sense when we jump into something else. The first example, x is less than or equal to 6. So these are all the possible numbers, right? All possible numbers that x can be that are less than or equal to 6. So we have 1 can be it, 2 can be it, 3 can be it, 4, 5, and even 6 because it's less than or equal to. However, 7 cannot be it, right? 7 cannot be it because 7 kind of makes this false. If we do 7, right, is 7 less than or equal to 6? No. 7 is greater than 6, so it cannot happen. But let's say look at numbers like or 8 or 100. 100 is not less than or equal to 6, so that cannot happen. So our limit is kind of 6. 6 is our limit, and then anything after this is okay. So we could kind of say the way we view this is we can say it's all the numbers from negative infinity to 6. Now, can x be 6? Yes, it can. So we use a bracket because it includes it. But when we get into negatives, we gotta really pay attention to this. Can we capture negative? Can we kind of contain negative? Right? And this is what that little bracket means. When we use that bracket, it means it's contained. Can we contain infinity or negative infinity? No, we cannot. We can't contain it because we don't know what infinity is. Infinity keeps growing forever and ever and ever and ever. And so I can never catch it. So that's why we use a parentheses. So whenever you deal with infinity or negative infinity, you can't really capture that. You can't really include it. So you have to leave it opened. So this is our interval notation, parentheses, negative infinity to 6. Now, if we were to draw this on a number line, it would be like this. So we have x is less than or equal to 6. I have my number line here. Let's use that as 0. It's going to be 1, 2, 3, 4, 5, and 6. Right? And we have 7, continue. All right, we know that it could be 6, so we could use a dark circle, right? And it's all the numbers that exist before that, right? Because we did say that -3 is less than 6, 1 is less than 6, 2 is less than 6, and so on. Even 6. 6 is valid. We could say 6 is less than or equal to 6 because they're both equal to each other. So how we would draw this on the number line is, boom, a dark circle and an arrow. Or another way we could do it is right? We could kind of use a bracket as well like this, and then just point the arrow, meaning that it's going to infinity. All right, let's look at another example. Let's look at something that's in between. We have -2 is less than or equal to x, and then let's say x is less than 7. So we're using two signs, meaning that x has to be greater than or equal to 2, so it can be -2, but it has to be less than 7. So if we were to look at it on a number line, right? Um, 0, 1, 2, 3, 4, 5, 6, 7. And on the other side, we have -1, -2, -3. So the way we look at this, right, is, well, x has to live between 2 and 7. So I have 2 here, and I have 7 here. Now, here it tells me that I can be -2 because it's saying x has to be greater than, or it could also be equal to 2. So that's why it's included. So I use a dark circle. But on the other side, right, x cannot be 7 because it's saying I have to be specifically less than 7. And 7 is not less than 7. They're the same thing. And it does not have the little, it does not have this little equal sign at the bottom to say that it's okay to be 7. So it's not okay to be 7, right? 7 is not less than 7. That is wrong. This would be correct because this says 7 is less than or equal to 7, which is correct, but this is not the case. So what we say is it is an open. I don't know what they're doing upstairs, but it's loud. So it's an open circle because it's not included, right? And then we just draw a little line between them, right? If we were to write it in the interval notation, then we would say, okay, x has to be between 2 and 7. Well, we don't include 7, so we have to use parentheses. But it's okay for x to be -2. Sorry, not 2, it's -2. It's okay for x to be -2, so we do little parentheses, brackets, -2, comma 7. That's how we view it. So here you're really just testing to see where x can be and is included and is not included. So let's look at one more example, such as 3 is greater than x. So here we could say I wrote it backwards, but x is this way. We'll write it that way. X is less than 3, right? Or 3 is greater than x. That means we have to look at numbers that are, x could be a number, but it has to be specifically less than 3. So 1 is true, 2 is true, but 3 is not true because 3 is not less than 3. They're actually equal to each other. And this sign says I want specifically numbers that are less than 3. All right, so if we were to draw our number line, we'll draw a number line. This is my 0. I have 1, 2, 3, 4, -1, and so on to negative infinity. So since I'm not including 3, I have to use an open circle. And all the numbers, all the possible numbers that x can be are actually all the way to negative. So we draw that little arrow because I could be 2, I could be 1, x could be 0, x could be -1, x could be -1000, and it'll still be less than 3. And so when we draw our interval notation, we say, well, it could go from all the numbers that are from negative infinity up till 3. All right, but remember how I said we cannot control, we cannot capture a negative infinity or a positive infinity. So it becomes a parentheses because remember, parentheses means that we cannot contain it, we cannot control it, we cannot capture it. And it cannot be 3, we cannot capture or contain 3 because it makes this inequality false. We can't say 3 is included because it makes it wrong. 3 is not less than 3. 3 is equal to 3, but not less than. And vice versa, we have other examples that kind of appear. If we were to have like 1 comma infinity, somebody raised a point towards the end of the class that if this was a point, it's not a point, it's just an interval notation. So the way we would write it is we draw a number line, we have 0, we have -1, -2, 1, 2, and 3, and 4, right? We know that the notation, or we're basically saying x could be all the numbers between 1 and infinity. It does not include 1 though. X cannot be 1, but it could be anything between 1 and infinity. So we have to draw a open circle and the line goes to positive infinity. All right. Another example or counterexample would be negative infinity, comma, 2, close parentheses. This tells me that x could be any number all the way to negative infinity, and it could go up to 2. And since there's a bracket here, that means we can include 2. I can be 2, or x can be 2. So when we draw it, it would be 0, 1, 2, 3, -1, -2, and so on to infinity. So here, do we use a circle or a Do we use an open circle or a darkened circle? We use a darkened circle because dark circles means that we include that number. I can be, x is allowed to be 2. And then we use an arrow to point that it's all the numbers from 2, including 2, all the way to negative infinity. And this is basically interval notation, which will help us determine a lot of things in the future, like range and domain, which I'm pretty sure you guys have already seen in your math classes. Last question. Right, we have 0, 1, 2, 3, 4, -1, -2, -3, -4, and -5. Right here, we're saying x can be between -5 and 3, and we are allowed to be 5, and we're allowed to be 3 because this bracket means that we're contained in it. So we go to 3. So I darken my circle because a darkened circle means it includes 3. X is allowed to be 3. And then at -5, we also darken our circle because x is allowed to be -5 as well. And we draw our line. So what this really means is that x, right, can be any number, including -5 and 3, and anything in between this is okay and valid. And that is interval notation.